So we want to look at the various ways that we can use this slope-intercept form, either to find the equation of the line or help us create our graph. So in this first example, we're going to look at the different kinds of information they can give us and how we can get that slope-intercept form out of the information. So your slope-intercept form is the y equals mx plus b. So you have these two variables. So your variables are y, and then your other variable is x. So when we're graphing, it's all about x and y coordinates. Then you have two values here that you need to fill in the blank for. So m is slope. So thinking about rise over run, or a difference in y values over a difference in x values. And then b is our y-intercept. So where do we intersect the y-axis? Okay, so this first example. So we want to fill in the blank, really fill in the blank for m and b so that we have our equation of the line. So our first example, they tell us exactly what slope is and exactly what the y-intercept is. So nothing really to solve here. We're just going to fill in the blank for y equals m times x. So we'll have 3/2 for m, and that's going to multiply with x. And then positive 4 for the y-intercept. So then plus 4. And we're done. So it's just a matter of plugging in. Some common mistakes that come up here when, even with an example like this, make sure you have x. We have to have y and x in these equations, and sometimes plugging in the values, x disappears, but that can't happen. Also, sometimes order jumbles up, so like I could also write this equation as y equals 4 plus 3/2 x, and that's exactly the same. Nothing actually different there. What you just need to keep in mind is that the slope always multiplies with x. So 3/2 has to multiply with our variable of x. And the intercept is this constant that's adding on, so it's all alone, just adding on to that term that has x involved. So with slope, just make sure it's attached to x with multiplication, and the y-intercept is just a constant term. All right, oops, that should be a plus symbol. Let's change that to addition. Here they just give us an equation. Now to change this to slope-intercept form, all we need to do is solve for y, because we would want to have y equals and then everything else for our equation. So, a few different ways to go about this. We can go ahead and move 5y so that it's all alone on the other side of the equation. So to do that, since we're adding 5y, I'm going to subtract 5y and then do that to both sides of the equation. So 0 minus 5y is just a negative 5y equals 7x plus 10. And I'm going to divide by negative 5. Now when you have addition of two terms like this, everything has to be divided by that number. So everything's being divided by negative 5 there. Now what happens when we do that is we can think of this as a separation of terms. So this is the same thing as 7x over negative 5 plus 10 over negative 5. And that can help in the simplification process. So I'm going to go one more step here of y equals, and then this 7x over negative 5, that's completely correct, but if you want to more clearly see the slope is the numerical coefficient of that term, which is coming from that 7 divided by negative 5. So what I can do is just rearrange that. So 7 divided by negative 5 is the same thing as negative 7/5. And then that's multiplying with x. And then 10 divided by negative 5 is just a negative 2. So I can go minus 2. And that right there is a more correct form of your final answer, especially we need to reduce anything that we can. So we absolutely need that -2 right there. And then having the -7/5 x, that can be more helpful for if we needed to go and graph. Okay, if we have a coordinate and a slope. So with the slope, they're telling us what m is. So what that does is it gets us started with our equation. So we'd have y equals mx, so -4 times x, and then plus b, but we don't know what b is. So b comes from the specific coordinate where x is 0 and y is whatever the intercept is. And they give us a coordinate, but for that coordinate x equals 2, so we can't use those values yet. So b is an unknown. What we can do here is with that coordinate, they're giving us an x value and a y value. So what we can do is plug in that coordinate. So what I'm going to do is with the equation, so I have y. Instead of writing y, I'm going to write -3 from that coordinate equals -4 times x, which x we're substituting in 2. So now we have this equation that's using the slope that's given and should work for this coordinate +2, -3. And then what we'll do is solve for b. So -3 equals -4 times 2, which is -8, plus b. I'm going to add 8 to both sides, which will give us 5 equals b. Now, a common mistake here is that you feel like you solved for your value and you're done, but you're not. We still need to make our equation with a y equals mx plus b. So our last piece is to go back to the equation that was in progress, making that y equals -4x plus b, and now we can plug in our value for b. So we'll have y equals -4x and then plus 5. So substituting in the value we found for b. So when you have a point and a slope, you get your equation started with a slope, plug in the coordinate, and then by plugging in the coordinate, you'll solve for your y-intercept, and with that, you can fill in the blanks to your equation. Okay, last one is given two coordinates. So what we're going to do first is find our slope. Then if we find our slope, we can go through this process that we just did for this previous example. So to find our slope, we have two coordinates, so we want to use that rule of x1, y1, x2, y2, and look at the difference of y values over the difference in x values. So for slope, I'm going to go y2 is -4 minus y1, which is +4, over x2 of 5 minus x1 of -4. So in the numerator, -4 minus 4, which is -8, over 5 plus 4. So I'm going to have a slope of -8 over 9. So from there, I'm going to go to this first step that we did of plugging in the slope. So I'll have y equals -8/9 x plus b. Now we're going to plug in a coordinate. So we have two coordinates to choose from. You can use -4, +4, or 5, -4, and it doesn't matter. Whichever one you plug in, you'll get the same y-intercept for. So you can just choose one of them. Doesn't matter which one. Something I do if it comes up, and unfortunately with this problem it won't be that easy, but especially with fractions, what I would look for is possibly an x-coordinate so that when I multiplied it would cancel out, but -4 won't cancel out with 9, +5 also won't cancel out with 9. So it doesn't really matter. I'm just going to use this first coordinate of -4, 4. So for y, I'm going to plug in +4 equals -8/9 times -4 plus b. And then we have some fraction work to do. So this will be a good review of fraction math, and I'll also show you how to do this with the calculator. So in terms of multiplying the -8/9, sorry, that gets a little messy there. 9ths times -4. So I'm gonna write everything the same, but multiplying two negatives is gonna make a positive. So those signs will just cancel out with each other. Fraction multiplication, think about how there's this denominator of 1 technically there. So multiplying fractions, you multiply the numerators and multiply the denominators. So I'm going to have this fraction that's positive. 8 times 4 is 32, and then divided by 9 plus b. Then what I want to do is subtract that 32/9 from both sides. So b, I'm going to need to move my work over a bit. B is going to come down to 4 minus 32/9. In fact, let me spread this out a little bit more just to get this good fraction review. So to add or subtract values that have different denominators. So right now, this 4 has a denominator of 1. What we want is that value of 4 to have a denominator of 9. So what we can do is multiply. So I want to multiply that denominator by 9, so that then I'll have a numerator over this denominator of 9. Whatever we multiply the denominator by, we also have to multiply the numerator. So that when we do this calculation, so 4 times 9 is 36, and then divided by 1 times 9, which is 9, now I have this fraction that's exactly equal to a whole number of 4. It's just in a different form so that we have this denominator of 9. And then we're going to subtract 32/9. So now that they have the same denominator, numerator is just 36 minus 32, which is 4, over this common denominator of 9. So some review of fraction math there. And once we find b, then it's just a matter of plugging in y equals our slope of -8/9 times x plus 4/9. Now through this, we could have been using our calculator just to give us like as far back as this -8/9 times -4. You could have gone to your calculator and just gone -8/9 times -4. But if you're showing your work for your steps, especially to have the most accurate answers, we want to use the fraction form. So we wouldn't want to round anything until the very end if we wanted that decimal form. So what you could use is this convert to fraction. So we can see our positive 32/9. And then what we could have done for the subtraction was what we did, 4 minus 32/9. And with that, we could have seen our 4/9 that we got out. Another way you can double check is using the graphing calculator. So we got this equation of the line. So let's plug it in. We got y equals -8/9 x plus 4/9. So what we can do to double check our answer is that this should be the line that goes through -4, +4. So let's find that -4, +4. So there's one of our coordinates right there. And then we should also be graphing the point +5, -4. So let's see, 0, 2, 4, so then halfway would be 5, and then it's landing right at -4. So you can use the Desmos graphing calculator to double check that that line is behaving exactly how it should be. Okay, so let's talk about graphing the line given our y equals mx plus b. So for this first case, and even the second case as well, actually. For both of these, we're given these equations. So to graph, it's really difficult to graph just at this stage right here. So what we want to do is solve for y, so that we can get it into the y equals mx plus b. So for both of these, we're going to solve for y. So 4x equals negative 5y. So to solve for y here, all I need to do is divide by negative 5. Divide by negative 5. So then I'm just going to switch the sides. This would be y equals, and then 4x divided by negative 5. Just to clearly show the slope, I'm going to make that the numerical coefficient, so negative 4/5 times x. So fitting the y equals mx plus b form, first thing I like to look at is the y-intercept, because then you have a point to start with. So for the y-intercept in this case, what we can notice is that there isn't a plus b term for this. There's nothing being added on. So with that, b is 0. It's like we have a plus 0 right there. So that would mean when x is 0, our y-intercept is also 0. So for graphing a coordinate, we have a coordinate 0, 0. Then to get a second coordinate, what we're going to do is look at slope. So writing this negative 4/5, we have this negative value, and I want to attach it either to the numerator or the denominator. It needs to go with one of them. I'm just going to put it in the numerator. So I'll make it negative 4 divided by positive 5, and that works great. So this is telling me, it's giving me directions to follow to find a second coordinate. So what the numerator tells me, so it tells me up versus down, and because this is negative, it's telling me to move down 4 units. And the denominator tells us how to move left and right. Well, it's positive, so that's how we move to the right, and then we're going to move to the right 5 units. So my starting point is going to be the y-intercept. So again, I like to think of this little bug and kind of tracking along, moving up, down, left, right, and the y-intercept gives us a starting spot. Then from there, I'm going to move down 4 units, and then to the right 5 units. 2, 3, 4, 5. So with that, moving down 4 to the right 5, I have the spot for my second coordinate. If you want to have more points, and that can help making a clear graph, you can reverse it. Like down 4, right 5 is the same thing as up 4, left 5. Or you could think of it as just kind of following this trend here, because it does map that trend. So what we could do is go to the left 5 and up 4, and that would give us another coordinate, so that when you're using your ruler or straight edge, whatever you're using to connect the dots, it's a little easier to line up than just with 2 points. For my computer, I have this line tool, so I'm just going to start it there, and then make sure it goes through each of the points, and then just attach arrows at the end. And that's our graph. Okay, with this one, we also want to solve for y. So let's see, I'm going to subtract 2x from both sides. So I'll have negative 3y equals negative 6 minus 2x. I'm going to divide everything by negative 3. Divide everything by negative 3. And that'll give us y equals, and then simplifying down, remember that negative 3 goes to each term. So I have this negative 6 divided by negative 3. Well, that would make a positive, and 6 divided by 3 is 2. So I have this positive 2. And then for my numerical coefficient of x, negative 2 divided by negative 3, well, that'll make a positive. So I'll have plus, and then 2 divided by 3, and that won't reduce down, so that'll just be 2/3, and then I can't forget my x. Okay, so first piece, I'm going to grab the y-intercept. So it's going to be a coordinate where x is 0, and then I just need my y value. So again, slope is always attached to x. Those are always multiplying together. It's that numerical term, the constant term, that's our y-intercept. So that'll be 2. So with that, I have a point to graph. 0, positive 2. Then for slope, I have positive 2/3. So that numerator is telling me to move up 2, and then the denominator is telling me to move to the right 3. So that'll be my starting point is the y-intercept, and then from there I'm going to move up 2 to the right 3, and that'll give me my next coordinate. Then I could follow it again, up 2, right 3 to get another one. Again, you could kind of start reversing the orders, like down 2, left 3, down 2, left 3, just to get some more points to help with the graphing. And then we use a straight edge or ruler to line up all of those points. And then put our arrows on, and there's our graph. Okay, let's just talk about these last special cases. So when we talked about slope initially, this vertical line, that's going to be where slope is undefined. And you can even see that if you think about choosing 2 points. So let's say I grab those 2 points. If I think about slope as rise over run, well, rise, I would have up 3. So I could have a value in the numerator, but then for run, we aren't moving left and right at all. So that's where we're dividing by 0, which we can't do. So slope is undefined. So writing the slope-intercept form of the line, what we have is just a value for x. X is equal to 3. We can see that we're on the x-axis at positive 3 for absolutely any value of y. So it doesn't really matter what we're doing along the y-axis, it's that x is always 3. So since x is always 3, that's our equation for the line. X equals positive 3. For the horizontal line, this is where our slope is going to be equal to 0. Now, if we thought about rise and run in this case, if you have 2 coordinates, let's say I chose those 2, for rise, there wouldn't be any rise. That would just be 0. But we move to the right 3 coordinates or however far, so you'll have a number for the denominator, and numerator of 0, denominator of any number is always 0. No matter what you divide 0 by, it always gives you 0. So with that, we have a slope of 0. And what we could actually see with this is our y-intercept. We have this y-intercept at positive 1. So we can actually fit our y equals mx plus b form in this case. We couldn't in this case because if we try to plug anything in for m, the whole equation falls apart because that's undefined. But in this case, we can actually plug in y equals m is 0 times x, and then our y-intercept is a positive 1. But by plugging in a slope of 0, that term just goes away because 0 times x would be 0. So what we end up with in this case is just y equals a number, and it'll be y equals positive 1. It doesn't matter what value we plug in for x, y is always positive 1. So those are our special lines. Then also how to make our graph from the equation of a line and finding that equation given all sorts of scenarios.